Now this is the first question. Let's see how to solve this question. In the diagram below, find the magnitude and direction of the resultant force. So let's start solving our question. The first thing we want to do is to find the angle of inclination between this 100 Newton force and this horizontal plane. To do that, we are going to use sum of angles on a straight line, and that will give us 180 degree minus the summation of these two angles. So we have 180 degree minus 105 degree plus 45 degree. When you solve that, you are going to get, what is 105 plus 45? So we get 150. 180 minus 150, we get 30 degree. So which means that this angle is 30 degree. The same way, we need to find the angle of inclination between this 350 Newton force here and this horizontal plane. Mind you, the angle between this 150 Newton force and this horizontal plane is right angle, 90 degree. So we can subtract this 45 from it, so we get 45 here. Now that we found our angles, the next thing is to start resolving all these forces into their various horizontal and vertical components. So let's have a table here. So we are starting with vertical. You can start with horizontal, anyhow you want it. So I have vertical component, which is Fy in Newton. Then I have horizontal component of these forces in Newton as well. So let's start. You can pick any of these forces as a starting point. So you can choose it randomly. Just make sure that you choose all these forces. Now I'm picking my 350 Newton and I'm moving anti-clockwise. So picking 350 Newton, observe something. I want to resolve it into vertical component. 350 Newton is pointing upward since I'm resolving into vertical components. So it means that it's going to be positive, not negative. So what angle? 45 degree. That is why we have 350 sine 45. Don't forget, resolving into vertical component is sine. So we have 350 sine 45 degree. Sine 45 degree is 0.7071. When you multiply it with 350, you have this. Approximating it into 2 decimal places, you have this. Now let's resolve the same force into horizontal components. Observe this 350 Newton as well. It will pull this object along this side, which is the right hand side. It will also pull this object upward. That is why it's positive or vertical. Pulling it along this right hand side, it will also be positive for horizontal. So we also have 350 cos 45 degrees. Since cos 45 degree and sin 45 degree is still the same thing, so we're going to have the same value. It now implies that when a force is inclined at angle 45 degree to the horizontal and that force is being applied to an object, when you resolve the force, it's going to have the same effect in both vertical plane and horizontal plane. So that is what we have here. Now let's quickly move to 150 Newton. So let's observe 150 Newton. To resolve it into vertical components, it is pointing upward, so that is positive. So we are going to have 150 sine 90 degree. And what is sine 90 degree? Sine 90 degree is 1. Multiplying it by 150, you have 150 Newton. So let's observe it. 150 Newton, the whole of 150 Newton will be used to pull this object upward. So which means that it's not going to have horizontal component, or the horizontal component will be 0. Unlike this one, you can't compare it to this 150. Just observe it. It is pulling this object vertically upward. So it means that there will not be horizontal component. And let's verify that. In verifying that, so we are still going to use our formula. That will give us 150 cos 90 degree. And what is cos 90 degree? Cos 90 degree is 0. 0 multiplied by 150, we have 0 here. We are done with 150. Let's move to 300 Newton. 300 Newton, before we start solving 300 Newton, let's observe the direction. Now, it's pointing towards the left hand side. So if you are resolving into horizontal components, it's going to be negative. Now for vertical components as well, let's see what will happen. Now, what is the angle of inclination of this 300 Newton with the horizontal plane? We can see that it is 0 or 180 degree. So 0, since we are using angle that is acute angle, so we are going to use 0 degree. If you use 180 degree, you are going to get 0 because sine 180 degree is also 0. But if you use it for cos 180 degree, you are going to get -1. So that is why you need to be careful. Sine 180 degree is 0. Cos 180 degree is -1. Be careful. Now let's go. For 300 Newton, we are going to have 300 what? Sine 0 degree. And what is sine 0 degree? Sine 0 is 0. Sine is an even function. Cosine is an odd function. So you are going to learn that in trigonometry. Now 300 sine 0 degree, we have 0 vertical component. It means that this 300 Newton, the whole of 300 Newton is being used to drag or pull this object along the horizontal plane. No vertical component of this force. So let's go. That will give us, for horizontal component, we also have minus 300 cos 0. And what is cos 0? 1. 1 multiplied by minus 300, we have minus 300. That is what I'm telling you with the knowledge of trigonometry. It is pointing towards the left hand side. That is why it is negative when you are resolving into horizontal components, if you are using that approach. Now, if you want to use the first one that I explained, you start reading your angle from here until you get here, and that is 180 degree. And what is cos 180 degree? -1. So at the end of the day, you still have minus 300 Newton. So let's move to the next force, which is 100 Newton. For 100 Newton as well, 100 Newton is pointing downward, negative for vertical. So that is why we have this minus 100 Newton sine 30 degree, and that is minus 50. Sine 30, 0.5 multiplied by minus 100, you get minus 50. And let's resolve it into horizontal components. Observe the direction first. Now it will pull this object along the left hand side, so it will be negative. It will be negative. So we now have 100 cos 30 degree. We are using this angle, cos 30 degree. So cos 30 degree is 0.860. When you multiply it by minus 100, you get this. Finally, to this 100 Newton. For this 100 Newton, observe it first. This 100 Newton you are seeing is pulling this object downward if you are resolving into vertical component, downward. So it will be negative. That is why we have minus 100 sine, which angle do we have here? 45 degree. When you do that, you are going to get minus 70.71. For the horizontal component, is pulling it along the right hand side. And that is going to give us what? 100 as positive, 100 cos 45 degree, and is 70.71 as shown. Now we've calculated the respective horizontal and vertical components of each force here. Now before we find the algebraic sum, let me quickly explain this. Now don't mind this diagram. Look at this 100 Newton here. If you look at this 100 Newton, the angle between this 100 Newton and the horizontal plane is 30 degree, and the angle between it and the vertical plane will be 60 degrees. 60 degrees is more than 30 degrees, so it means that the direction should be a bit close to horizontal plane. So which means that the closer a force to a particular plane, while resolving it, the more force it gives to that plane. That is what I want to say. Looking at this 100 Newton here, you discover that when you resolve it, the force that is being given to the horizontal component is more, which is 86.60. Removing the minus. The minus is just showing you the direction of the force. The other force here, you discover that 150 Newton is on the vertical plane. So it is on the vertical plane, it is close to vertical plane. So that is why the whole of 150 Newton will be given to what? Vertical plane, nothing given to horizontal plane. The same thing applies to 300 Newton. If you look at it, the whole of 300 Newton is given to the horizontal plane because 300 Newton aligns with the horizontal plane. So nothing left for vertical plane. And if you look at 350 Newton and this 100 Newton here, you discover that they share the same amount of force into vertical plane and horizontal plane because the distance in angle between them are the same. First, the next thing is to find the algebraic sum of this force. Now let's go ahead and do that. In doing that, let's start with the vertical components. So we have 247.48 plus 150 plus 0 minus 50, finally minus 70.71. When you do that, you are going to get this. Now to horizontal components. To our horizontal component as well, we are going to have 247.48 plus 0 minus 300, then minus 86.60 plus 70.71. Doing this, we are going to get a negative force here. It now means that all these force systems have been converted into coplanar force system. This coplanar force system is acting in two planes. We have vertical plane and horizontal plane. Just one. Now let's draw our diagram to visualize what I'm saying. Instead of having this force, if you just have two forces acting like this, it will still have the same effect that all these forces are having. So this is what will happen. Now with this diagram, we can go ahead and find the resultant force using triangular law of vector. So what will be the direction of our resultant? Resultant will act towards that direction, and we can use trigonometry and triangular law of vector to find the resultant. Now with our diagram, this angle between this resultant and the horizontal plane is theta, right? And it's going to be the angle here as well, as shown, this angle. Now let's use Pythagoras theorem. Using triangular law of vector, which says that if two adjacent sides represent two forces acting on a system in their magnitude and direction, the third side will be the resultant of the two forces. Now let's now apply that using Pythagoras theorem. So let's quickly use our Pythagoras theorem. So we know that Fr, this resultant force, will be the square root of the summation of the horizontal component square plus the summation of the vertical component square. Applying that, we are going to have this 276.77 square plus minus 68.89 square. Minus is just showing you direction, so the minus will be taken care of. Now doing this, what are we going to get? Pressing your calculator, you are going to get this. So 276.77 square, you have this, and minus 68.89 square, you are going to have this. So when you sum them up, you are going to have this. The square root will give you this. So that is the resultant force. Now to find the direction of the resultant force, which means we want to find this angle. Finding that angle, we are going to use trigonometry as well. So we use tangent. We know that the tan is equal to tan inverse of Fy divided by Fx. Total sum of the vertical component divided by total sum of the horizontal component. Be careful here. Now you can do away with your sign if you want to get angle that is acute. That is what happened here. Now inserting them, doing away with your sign, and find the tan inverse of 4.017. How do I get 4.0176? Dividing these two guys. Just insert them in your formula. When you find the tan inverse, you get 76.02 degree. And that will be the same thing with 103.98 degree. I will show you. 76.02 degrees is not the same as 103.98 degree. But the tangent of this value will be the same. What did I mean? Now let's go ahead and find the other angle. The other angle just means that when you start reading your angle, going anti-clockwise, moving like this, the angle that you get, which is 103.98. And even though when you subtract 76.02, subtracting it from 180 degree angle on a straight line, you get this. That is how we got this. For every angle, we also have equal angles at different quadrats. You can go ahead and watch my video on trigonometry to verify that. Now we found the angle, which is the direction, and the resultant as well, the magnitude of the resultant. What is the meaning of that? It means that instead of having these multiple forces, concurrent force system, we can have just a single force like this, which is the resultant. Assuming this direction and it's going to have the same effects that all these forces are having on this object. Since we have verified that this object is not going to be stable, so it's going to move, it's going to be displaced by this force moving towards this direction. Now to balance it, which means to find the equilibrant, to balance it up, you must add a force that will make it stable, which is the equilibrant. Which force are you going to add? You are going to add the same force that has the same value with this resultant, so which is also 285.21 Newton, but in opposite direction. So that is what we call equilibrant. This is resultant and this is equilibrant. The same magnitude, different direction. That is how to solve question like this. Now there's another question which is sent to me on the group, which is a force of 25 Newton inclined at north 38 degree east and another force 15 Newton inclined at north 22 degree west acts on an object. Calculate the magnitude of their resultant. We want to use two different methods to solve this question. The first method is we want to use resolution of force that we've known. Let's see how to apply it. And now to apply it, we need to have a diagram. So that is why we are going to draw the free body diagram for this question. Let's interpret our question. So the first thing is to draw 4 cardinal points. Why are we drawing 4 cardinal points? This thing looks like bearing. This is just like a bearing question in mathematics. So let's have our 4 cardinal points: north, south, east and west. Now let's fix this angle. North 38 degree simply means that the angle between the knots moving clockwise, and you measure it until you get 38 degree. And north 22 degree west means the angle between this north pole moving anti-clockwise until you get 22 degree. So that is the concept. This one is compass bearing. How to fix compass bearing. Now let's fix the angle and the force. The first one is 38 degree north 38 degree east, which is shown. Which force is acting, which is 25 Newton as shown. The next one is what? 22 degree north 22 degree west, which is this. Which force is acting? 15 Newton. Since we want to use resolution of force, it is proper for us to find this angle. Now let's find the angle of inclination with the horizontal plane. The first one is close, 25 is close to this one, so we choose that angle, and which is 52 degree. How do I get 52 degree? That is 90 degree minus 38. Don't forget that. 52 degree. Now let's find the other one. It's close to this, which is 68. That's minus 22, 68 degree. Now we can start resolving our force. Now resolving it, we have vertical component as shown and we have our horizontal component as shown. We pick the first force. So we are starting with 15. So that will give us, for vertical component, 15 sine 68. When you press your calculator for this, you get 13.91. So we want to find the vertical first, then we now move to the horizontal force. Now the second one, let's find the vertical component of the second one, which is 25 sine 52 degree and 19.70. So you can choose to find the horizontal, vertical, or you find it this way. Now let's pick the next one. Let's find the horizontal components of these forces. Now the first one is 15. For horizontal components of 15, we need to observe the diagram and the direction. You see that when I do the vertical components, they are all positive. Why are they positive? They are all pointing upward. 25 pointing upward, 25 pointing upward. Now for horizontal component, 15 is pointing towards the left hand side. That is why it's negative. So we have minus 15 cos 68 degree and we get this. Now for 25 is pointing towards the right hand side. That is why it is positive. 25 cos 52 degree, which is 15.39. So the next thing is to find the algebraic sum. What is the algebraic sum for Fy? What are we going to add together for Fy? Fy, we have 13.91 plus 19.70, which is 33.61. You can press a calculator for this. What about Fx? That is 15.39 minus 5.62, and we get 9.77. The next thing is we can have our diagram. I don't need to start drawing again. We have diagram. So why are we having this diagram this way? Let me see if you know why our right angle triangle is facing this side. It's facing this side because the vertical component is positive and the horizontal component is also positive. That is why our triangle is facing this side. Now we can fix this triangle. So this, for the horizontal component, that's 33.61 Newton here. For vertical component, that's 9.77 Newton here. And where is our resultant force? This hypotenuse. What is FR? FR will be square root of this square and this square. So that is 9.77 square plus 33.61 square. Solving that, we are going to get 9.77 square is this. Pressing your calculator. 33.61 square is this. Adding them together. So you are going to get square root of 1225.08. And the most funny part of it is that, and that is 1225.08, and 1225 is a perfect square. We have small amount of number that we can neglect here, which is 0.08. But nevertheless, when you press the square root of this guy, you are going to get 35.00, approximately 35.0. So that is why we have 35.0 Newton. It's actually simple. That's the first method. Now, if you want to solve it very fast, this method is also fast. But the second method, you can still use it. I think the second method is faster than this. Now, for the second method, let's see how to solve this using another method. The second method, you don't need to find this angle of inclination with this horizontal. You don't need to find it. What you just need to do is you use parallelogram law of vector and triangular law of vector. You combine the two together, use it to solve this. What is parallelogram law of vector? Parallelogram law of vector states that if two adjacent sides of a parallelogram represent two different forces acting in opposite direction, the diagonal drawn from the point of intersection will be the resultant force. That is what it's saying. What is triangular law of vector saying? It's almost the same thing. It's saying that the two adjacent sides of a triangle, if it is representing two different forces in two different directions, the third side represents the resultant force. And that is what we have been using since. Now let's now combine the two together to use it to solve this. How do we use it to solve it? This is our diagram. This has turned to this. Why do we have 60 degrees here? 22 plus 38 degrees. So the angle here at this vertex is 60 degrees. And we have 25 Newton acting. Don't forget we are dealing with vector. It has direction and 15 degrees acting this way. How do we now apply triangular law of vector and parallelogram law of vector? Now this is one of the mistakes that students used to do. They used to make those mistakes. And they believe that triangular law of vector, when you have something like this, you just need to complete this triangle and use your knowledge of trigonometry to find that third side. If you do it, you are going to miss it. This angle is not equals to 90 degrees. So if you have a right angle triangle, let's say this is right angle, that is when you can now just draw hypotenuse and find that side. If it is acute or obtuse, it is more than 90 degrees or less than 90 degrees, you must apply parallelogram law of vector. And later on, you now use your triangular law of vector. So don't just complete this and you now form a triangle, and because you know how to apply sine rule, cosine rule, now want to use it to solve this, you will miss this. So let's apply parallelogram law of vector. What it's saying is, this force is acting along this direction. You can draw a parallel force to it, drawing it here. Now we now have parallelogram. If you complete this, you have a parallelogram. Now this force has been transposed here. That is the implication of that. Now what it's now saying is that the diagonal drawn from the point of intersection of the two forces. Now this is the diagonal here. This is the intersection of the two forces here. Now if you draw the diagonal up to these 2 points to meet this, that is what it's saying. The funnest part of parallelogram law of vector is you will be given just two sides, and how do we now see parallelogram here? That is what I'm showing you. Seeing parallelogram law here means that you transpose this to this point, and when you now complete this, you have formed a parallelogram. So this angle is 60 degrees. Now parallelogram law of vector, let's now apply it. You now draw the diagonal from the point of intersection. Before drawing it, let's fix this angle. Let me quickly use geometry to explain something for you guys. If this is 60 degrees, the angle that is formed here will also be 60 degrees. Why? Corresponding angle. We are extending this. And what will be the interior angles here? This is 120, angle on a straight line. You must understand this. Now let's now fix the parallelogram law of vector. Diagonal drawn from point of intersection. Here we go. So this represents our what? Our resultant force. So this 15 Newton that is acting here, you can bring it here. That is what I'm telling you. 25 is here. You have 120 degrees inside here. If you want to apply cosine rule, now you will use 120 degrees. And the funnest part of it is that cosine as a trigonometric function is an odd function, and when angle is more than 90 degrees in between the range of obtuse, cosine in between the range of obtuse will be negative, and later on you will get negative for cos 120 degrees. And cos 120 degrees and cos 60 degrees, the only difference between them is minus sign. So which means that you can choose to use the angle of inclination between the two angles instead of using this 120 degrees. So if you want to use 120 degrees, you must apply cosine rule. But if you want to use 60 degrees, you are still applying cosine rule, but you will change that. This is what I'm saying to understand it. You have your triangle, and we want to find FR, which happens to be this side. 15 is this side. So using parallelogram law of vector, which is this, you see that this resembles cosine rule. For cosine rule, this will be minus. And if this is minus and you want to apply cosine rule, don't use the angle in between these two guys. When you use this 60 degrees, you are going to miss this. And the funnest part of it, if it is multiple choice question, the examiner will intentionally put that particular answer there. So you will now solve it, you will still see the same option there and pick it. And it is the wrong answer. Be careful. Now, don't use this 60 degrees if you want to apply cosine rule. But if you are using this formula here, which means you have changed this to plus sign, you must use this 60 degrees. Don't go ahead and use this 120 degrees while using this formula. What this formula is telling us is the angle between these two forces, because we derive this formula from cosine rule. This is cosine rule. If you later find the value of cos 120 degrees, you are going to get negative sign of the value of cos 60 degrees. And when you put it in this formula, this thing will later turn to plus. I've explained this. So if you want to understand this better, I have a playlist on trigonometry. Kindly watch this trigonometry playlist. Now let's apply a formula. Applying this, you have this guy over here, which is square root of this guy. Now let's insert our values. So which means that we have 15 square plus 25 square plus 2 times 15 times 25 cos 60 degrees. When you do that, you have 225 plus 625 plus 375. When you do cos 60 degrees, 0.8660. Multiplying it by, when you do cos 60 degrees, that's 0.5. Multiplying it by 2. 2 is gone. 15 times 25, you have 375. Adding it up, you get square root of 1225. And when you find the square root, you have 30 Newton, which is still the same thing as what we are solved earlier, but you can see that it's actually simple. Now I expect you not to miss any exam, be it A-level physics question that assume this format. You should be able to solve it and get your answer correctly using the approach I've explained in this video. If you haven't subscribed to this channel, kindly subscribe to this channel, like my video, share my video, comment your view about this video. And our next video in this playlist is going to be Moments of Force. Thank you. Stay blessed. Bye for now.